All right, in the last video what we did is we motivated this idea of moving charges, right? And so what we're going to start dealing with is this concept of a moving charge or a current. So what we had last time was this separation of charge between two plates. And that turns out to play a critical role in how we move charge about because the separation, the physical separation of two charges, of charges, allows us to then connect them with some sort of wire which allows electrons to produce a current, or the movement of electrons from one place to another, right? They are attracted to these positively charged atomic cores, and so if we can separate the charge in some way and then connect them with some metal wire which allows them to move around, they will rush over onto the positively charged plate. Now, the way that's actually done in practice is it's a chemical process by which you sort of separate charge using a chemical reaction. You sort of degrade some metal material which allows you to separate the electrons from their atomic cores, and then you connect these two pieces of material together and the electrons will kind of rush over across. Now that process is pretty complicated, and it's actually under a lot of research because people want really good batteries that store a lot of charge. So we're not going to really dig into the fundamental chemistry or physics of that, but instead we're going to make a model of how that would work, how we would actually separate charges. So what we'll do is we'll go with a mechanical model where we have two plates. One is a positively charged plate and one is a negatively charged plate. And between those plates we can think of having a conveyor belt that sort of rotates like this, which takes electrons from the positively charged plate and dumps them on to the negatively charged plate. And then this allows us to connect these two plates with a thick piece of wire. And it's very similar to this. The electrons are going to rush around in this direction and end up back on the positively charged plate, right? So this is the way that the electrons would actually move in this wire, replenishing the positively charged plate with some electrons that are then peeled off with this conveyor belt back onto the negatively charged plate. And this right here, this thing is our mechanical model of a battery. And like I said, the underlying chemistry and physics that real batteries use is a little more complicated than we want to get into, but this idea of just separating these charges gets us enough to understand how the current can flow. Now, the game that we're going to play is that this conveyor belt ensures that we have a constant current throughout this wire, right? So our assumption that we're going to make is what we call a steady state assumption, which is that we have a constant current. And for most of the circuits we're going to analyze in this class, that assumption is going to be true. That is, that at every point along the wire, the current is exactly the same. So to summarize, to drive a current, you need to separate charge. We're going to separate charge with this idea of a mechanical model of a battery. We're going to track the electrons as they go through the wire under the assumption that the current is constant. So we'll dig into the details of how this actually occurs in the next few videos.